these down. These should be refreshers. You've been seeing this since Algebra 1 days, hopefully. So our first one, the product rule. Remember the good old product rule? If you have the same bases for your powers, and they're being multiplied, you add your exponents together. So the power rule of exponents, you have a to the m times a to the n is equal to a to the m plus n. Yeah? So for example, if I had x to the 5th times x to the 3rd, that would become what? X to the 8th. Good. Remember those rules? Andrew, yeah? Remember that? All right, next one we have is the quotient rule.
Nice.
When you divide like bases with exponents, you subtract your exponents. You do not need to memorize the names of these rules. You just need to make sure you know how to use them. So keeping in mind, these are just kind of shortcuts on how to simplify exponents. Up here we had x to the 5th times x to the 3rd. Well, x to the 5th is 5 x's, right? And x to the 3rd is 3 x's. So the reason why we add them together is because I have 8 total x's. Well, the same thing applies for division. If I had x to the 5th divided by x to the 3rd, it would be what? X to the 2nd. Because it's like having 5 x's in my numerator, 3 x's in my denominator. And if I start dividing out my like x's, I'm left with how many x's? 2. What if I were to flip this around and make it 3 on the top and 5 on the bottom?
1 over x squared.
Yeah, why would it be 1 over x squared?
Because you have 2 x's on the bottom.
Right, because here this is the same as having 3 x's in the numerator, 5 x's in the denominator, cancel them out, and you're left with 2 x's in the denominator. So you have to think about, if I had 5 here, 3 here, canceling them out, I'm going to be left with x squared. If I have 3 here, 5 here, cancel them out, I'm going to be left with x squared in the denominator. Okay? So quotients. We got the power rule. We've got the quotient rule. Next one, the 0 exponent rule. That's the easiest one and our favorite one. Anything to the 0 power is just equal to 1. So if I give you some very elaborate looking exponent with lots of variables and lots of exponents, and then I put it in parentheses and put it to the 0 power, you're like, yes, it's just 1. Final answer. Negative exponents. You take the reciprocal of it and make it become positive. So a to the negative n is equal to 1 over a to the n. Say I had x to the negative 3. That would be what?
1 over x to the 3.
1 over x to the 3rd. Good. What if I had 3x to the negative 3?
1 over 3x to the 3rd.
Yeah, what's the exponent on the 3 right there?
1.
Yeah, it's power of 1, right?
I thought you wanted his power of 0.
Yeah, that was supposed to be a blank. So that's a power of 1. Is that power of 1 positive or negative? Positive. So it wouldn't go down into the denominator, and it would be 3 over x to the negative 3. All right, so we got 0 exponent. We've got negative exponent. Now let's go to the reverse of that. If I had 1 over a to the negative n, that would make it move back up to the numerator. So if I had, let's say, 1 over x to the negative 3, To make this negative 3 become a positive 3, we would shift it up to the numerator, which would just make it become x to the positive 3. What if I had negative exponents on both the numerator and the denominator? Yeah, you would just flip it. So if I had a to the negative n over b to the negative m, and I need to make my exponents become a positive, you would just flip the whole thing and make your exponents become positive. So b to the m over a to the n. Okay, almost there. Power rule. So we had power of products. Now we're doing the power rule. So if you have a to the m to the nth power, you're going to multiply your exponents together. So if I had x to the third to the fifth power, it would become x to the 15th. Reason being, this fifth power is telling me that I'm taking 5 x to the thirds. Well, what does that look like? X to the third, x to the third, x to the third, x to the third, x to the third. How many x's are in each of those? 3, right? 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. So how many x's do you have in total? 15. So that's why it's a multiplying. So instead of writing out all the x's, that's the shortcut. If I have 2 different terms inside my parenthesis, so here the bases are different, A and B, they're not the same, and they're being taken to the same power, I need to, sometimes people say the word distribute, which is kind of counterintuitive because distribute is really multiplying the coefficient. But you multiply that exponent to the exponents of both of those bases. So it would become a to the m times b to the m. If I had a quotient instead of a product, it's just the same thing. You have to take the m to both powers of the numerator and the denominator. I don't know why it says b to the b. That should say b to the m. That's a typo. So, for example, up here, if I had 2x to the third squared, what are my 2 different terms inside the parentheses? A 2, what's the power on the 2? A 1. So when I take that power of 2 times the power of 1, I'm going to get 2 squared. And here my power is 3. When I take 3 and multiply that with 2, I'm going to get 6. So that would get me to 4x to the 6th. Down here, if I had, let's say, x squared over y, and I was squaring that whole thing, what would I get in the numerator? X to the 4th and y to the 2nd, because it's 2 times 1. All right, last one. Quotient with a negative exponent. We have a over b, and it's being taken to a negative power. The first thing I would do to make it become a positive power is to just take the reciprocal. All right, we're just going to go through a bunch of examples. Are you ready? All right, first one is up. Make it nice and easy. Probably don't even have to write this one down. 3 to the 4th times 3 to the 7th. What are we going to do? Add them to get 3 to the 11th. Good. Simplify, done. I'm just going to be simplifying all of these. Next one. 5 to the 3rd times 5. Yeah, because that's a power of 1, so it would be 5 to the 4th. Okay, you can just leave it like that. If the directions would say evaluate, then you would want an actual number for your answer. So whatever 5 to the 4th would be 25 times 25, so 625. But it just says simplify, so we'll leave it. Y to the 3rd times y to the 8th times y to the 2nd. Y to the 13th, good. So far, so good. Not too crazy. How about this one? We got 5y squared being multiplied by negative 3y to the 4th. Now, for me personally, I like to rewrite this, because I can, because the commutative property of multiplication allows me to rearrange everything. Because my only power here is a 1, and my only power here is a 1, I don't have to do any power to a powers. So I'm going to rearrange this, and I'm going to put my numbers next to each other, my coefficients. So 5 and negative 3. And then I'm going to order my variables together. So it makes it a little bit easier to see what's happening. So 5 times negative 3 makes negative 15, and it's going to be y to the 6th power. Because we have to add 2 and 4, right? Okay. Still so far, we're okay. What's this one going to be? 1. 6 to the 0 is 1. I'm not even going to write that down. What was that going to be? 1. Just because I put parentheses around it, still is going to be 1. What about 2 to the negative 3? One over 2 to the 3rd. What is 2 to the 3rd power?
8.
8, yeah. Okay. Starting off easy, and we'll make ourselves get a little bit harder. 5z to the negative 3. What will be your first move? How can I make that negative 3 a positive 3? Yeah, and make sure we keep this in parentheses, because I have to take both of those two different terms, the 5 and the z, and take it to the 3rd power. So then we would get 1 over 5 to the 3rd, z to the 3rd. Now for a rule of thumb, if you ever have numbers with variables, then you should take the numbers to the actual numbers. If it just was a number, you could just leave it as 2 to the 3rd. If you wanted to take it to 1 over 8, you could. So what is 5 to the 3rd? 5 times 5 is 25. 125. So then this would simplify to 1 over 125, z to the 3rd. Okay. What about this one? Negative m to the negative 2. Told you we're going to do a lot of examples.
Negative 1 over m squared.
Why is it negative 1? You're right, Kevin.
It's not
Yeah, what's the coefficient in front of the m right now?
negative 1.
Yeah, that's kind of like having a negative 1 times m to the negative 2. Well, what's the power on the negative 1? 1. So that's not going to go anywhere. And negative 1 to the 1 power stays a negative 1. So negative 1 over m squared. I would just leave that negative out in front. Okay. How about 1 over 2 to the negative 3rd? Yeah, it'd just be 2 to the 3rd. So you just make that a positive by moving it up into the numerator. Not throwing anything too crazy out at you, am I? But this one, 2 to the negative 3 over 3 to the negative 2.
3 over 2 to the 3rd.
Yeah, so 3 squared over 2 to the 3rd. For fun, if we wanted to take it to numbers, what is 3 squared? 9 over 8. Okay. Let's see if we can get to some crazy ones. We don't need to do those subtracting ones. There's a lot of these. All right, let's try this one out. Negative 2m to the 5th all over z. And then we're going to take that whole thing and cube it. What would be your first move? How many terms do I have in my numerator? I've got 2. I've got a negative 2 and I've got an m to the 5th. So I'm going to take the negative 2 and I'm going to take it to the 3rd power. And I'm going to take that m to the 5th to the 3rd power. And then I have to take the z, my denominator, to the 3rd power. So what do I get in the numerator? What's negative 2 times negative 2 times negative 2? Negative 8. And then m to the 15th, because power over power makes us multiply. And over z to the 3rd. Alright, do I have any other crazy ones? Those are all really easy. How about this one? X to the negative 4, y squared, all over x squared, y to the negative 5. Now there's lots of different ways you could do this. What I personally would do is I would move everything so that I get to positive exponents. So I would move this x to the negative 4th down to make it a positive 4. And I would move this negative 5 up to make it a positive 5, which would give me y squared y to the 5th over x squared x to the 4th. So my numerator would then go to y to the 7th over x to the 6th. Yeah? We could have subtracted. We could have did a negative 4 minus 2, which would have gotten us x to the negative 6. And then we could have done a 2 minus a negative 5, which would have got us y to the 7th, which then we could have taken it to y to the 7th over x to the 6th. Either way, it will get you there. All right, we feeling pretty good with these? See if you can do this last one on your own. Then we'll do scientific notation. Missing a 4. You guys agree with what I got? Now be careful, when you make this into a positive and you flip this negative, or y to the negative 2 power, that still is going to stay a negative, because the only thing that's changing is that positive. And then 3 squared is 9, and my 4, here I had 4 x's, here I had 3 x's, so canceling those out leaves me with 1 x. Sending that y to the negative 2 down would get me 4 y's in the denominator. All right, what do you guys remember about scientific notation? I had, this is my number, How would I write that in scientific notation? 1,625,000. 10 to the 1, 2, 3, 4, 5, 6. Yeah? What if I had 0.000012? How would I write that in scientific notation? Times 10 to the 1, 2, 3, 4, 5, negative fifth. Right? I've been doing scientific notation and science and whatever else. So, what if we had a problem like this that we needed to use scientific notation to evaluate?
Yeah, we just went to.
You could easily solve this. So we have 1,920,000, yeah, times 0.0015 being divided by 0.000032 times 45,000. So the easiest way to do this, without a lot of thought process, is to convert all of those numbers into scientific notation. So let's start with the 1,920,000. That would become what? 1.92 times 10 to the 6th. Good. And I'm going to put another times. 0.0015 would be 1.5 times 10 to the negative 3 all over 3.2 times 10 to the negative 5 times 4.5 times 10 to the 4. Good. All right, do we have like bases anywhere? Are you sure? Tens are like bases, right? So what can I do with the exponents of like bases? So 10 to the 6th times 10 to the negative 3 would be 10 to the 3rd. In my denominator, what would my base of 10's exponent be? Negative 1. So now I do have to do a little bit of calculator work, unless you want to take 1.92 and multiply it by 1.5 by hand. So 1.92 times 1.5 is 2.88. And then 3.2 times 4.5 is 14.4. Okay. So what would I do with my exponents here when I'm dividing like bases? Subtract them. So it's 3 minus a negative 4, or negative 1. 4. That's not the answer out loud. So that becomes a 10 to the 4th. And then if I take 2.88 divided by 14.4, I get 0.2. Well, my final answer should be written in scientific notation. That's not scientific notation yet. So remember, you have to have an integer larger than 1 in front of your decimal place. So if I were to move this decimal place over one more spot, what would that become? Would it be 5 or 3? It would be 3, right? And the reason being, if I just focus on writing this in scientific notation, this would be 2 times 10 to the negative 1, right? Just the 0.2. And if I multiply that by 10 to the 4th, well, 4 negative 1 makes 3, so we get 10 to the 3rd. So 2 times 10 to the 3rd, which would really be what number? 2,000? Yeah. 3 zeros? Yeah. Okay. Let's do a word problem.
Why is there always a word problem?
Because you gotta apply it. Distance from the Earth to the Sun is 9.3 times 10 to the 7th miles away. It's a lot of miles. How long would it take a rocket traveling at 32.10 to the 3rd miles per hour to reach the sun. Well, what's our distance formula? Distance equals rate times time. What number is going to go in place of distance? The 9.3 times 10 to the 7th. What's going to go in place of rate? Times 10 to the 3rd. And what's going in place of time? T, because that's what we're trying to solve for. So how do I get T by itself? Divide by 2.3 times 10 to the 3rd. So how do I evaluate that fraction on the left side? What are my exponents going to be on the 10? 4. So times 10 to the 4th. 9.3 divided by 3.2 is 2.90625 times 10 to the 4th. Turn that into an actual number. How do I convert that to a real number in standard form? Move over 4 places. 1, 2, 3, 4. So that really is 29062.5. So 29,062.5 hours. That's a lot of hours. How many days is that? 29062.5. How would I figure out days? Divide that by 24. So that's 1,210.9 days. Yeah, so we'll round it to 11. 1,211. So then how would I take that to years? I know. Let's see what we get. So it's not. Well, we don't know if that leap year falls in there. So it's about 3 years. 3 years to get to the sun, traveling at. What is that? 3,200 miles per hour.
Oh my god, that would be so fun.
That'd be really fast. All right. Do you want to do some practice stuff on practice base or just